Good day, everyone. We are now in topic 1.3 of our basic calculus subject, which talks about illustration of limit theorems. Okay, so we have limit loss. The competency we are going to tackle for this session is you are expected to illustrate the limit theorem. So after learning or listening this video or audio video lesson, you are expected to illustrate the different limit theorems. Okay, so let us first review our previous lesson. Let us recall that in lesson 1, it showed how limits can be determined through either a table of values or graph of a function. You might ask, is it always to construct a table or graph the function in order to determine a limit? Because kung ato i-analyze ang situation, filling in a table of values sometimes requires us a very tedious calculations. No, ang lisura ba dya nga maghatag tag value sa x nga na ay mga point something in order for us to analyze unsay value sa y when the x gets closer and closer to a certain constant. And then from the left pagadjud o from the right nga values mo nang taas and then langan para sa atong part. Likewise, a graph may be difficult to sketch because it requires our background knowledge on how to graph the different equations. However, this should not be reasons for us to fail in order to determine the limit. Okay, so memory recall ko ng taog na bay atong hinumduman on how to evaluate the limit. So we are going to investigate the graph. Mangita ta first og the limit of the function as x approaches -2 from the right. Then investigate also from the right and from the left. The next, limits f of x as x approaches 0 from the left, then from the right. Then the limit of f of x as x approaches 4 from the left and from the right. So here are the solutions. So to find the limit of f of x as x approaches -2 from the left, so this is -2, x equals -2, from the left of -2, so atong tanahon, when x is approaching -2, ang imo pong y is also approaching to +1, so that's why the limit is 1. And the limit of f of x as x approaches -2 from the right. So, huwag mo tanaw ang from the right. There no. From the right of -2. So, ang imo pong value sa y gets closer and closer to -2. So, that's why we can say that the limit of f of x as x approaches -2 from the right is -2. So, since 1 and -2 are not equal, therefore, we can conclude that the limit of f of x as x approaches -2 does not exist. No, okay? 1 mani, o -2, meaning, wa mo exist. Kay, wa sila moabot sa the same nga value in y. Okay. Next is the limit of f of x as x approaches 0 from the left is 0. So, ang x mo approach sa 0 from the left, ang answer is 0. Whereas, ang limit sa function as x approaches 0 from the right, asa man himpadong. So, dili na to ma-estimate because the graph is half of a parabola opening downward, extended padong sa ubos to extended padong sa negative infinity. So, that's why the answer of the limit of the function as x approaches 0 from the right is negative infinity. Okay, ang from the left is 0, and from the right is negative infinity. Therefore, we can say that the limit of f of x as x approaches 0 does not exist. Pareha dire no, does not exist. Ang ubos second po does not exist. Okay, next is finding the limit of the function as x approaches 4 from the left. 4 from the left. Kaning part. So, notice that ang graph has dili na ito ma-determine because of its oscillation. So, therefore, we can say that the limit of the function as x approaches 4 from the left does not exist. And from the right pod, we have here the graph is half of a parabola opening upward. So, extended padong babaw. So, wa siya mo approach og certain constant. So, that's why the y is approaching towards the positive infinity. So, ang dire does not exist. Ang left, ang from the right is positive infinity. Therefore, we can conclude that the limit of f of x as x approaches 4 does not exist. Okay, so these are the different situations wherein naglain-lain po ang mga answer sa limit of a certain function. Okay, so let us now proceed to limit laws. What is the first limit? Limit law. The first one talks about the limit of a constant. So when we say the limit of the constant is itself, if we assume that the constant is k, so we can say that the limit of k as x approaches c is equal to k. So, for example, if the given is limit of -5 as x approaches 0. So, unsa may answer? So, ingon man diri nga itself, so meaning the limit of -5 as x approaches 0 is also -5. Okay? Another situation, if we have the limit of pi as x approaches -8, so ang answer, kaya ang pi kay constant pa no, na 3 point something. So, ang answer is pi. Okay? The limit of 1/2 as x approaches ang 5. So, since ang 1/2 kay constant man, so ang answer is 1/2 gihapon. Okay? So, sa na, no? Okay, next is we have the second law or the second theorem, which talk about the limit of x as x approaches c is equal to c. So this be thought of as the substitution law because x is simply substituted by c. So therefore, if we have example, the limit of x as x approaches c is equal to c. Okay, and some specific example ani. If we have the limit of x as x approaches -3/4. So ang answer is -3/4. Because by substitution, substitute mo ang x with -3/4, so diretso ra nga -3/4. So unsay gi-approach sa imong x, mo po'y answer. Okay, another, you have the limit of x as x approaches 0.5. So ang value is substitute ra nato dito ang x, which is 0.5. So the answer would be 0.5. Okay, one more. The limit of x as x approaches -1,000 is equal to -1,000. Okay. Next is we have the constant multiple theorem. Sama ng constant multiple theorem. This says that the limit of the multiple of a function is simply that multiple of the limit of the function. So, the limit of k times f of x is equal to k times the limit of f of x as x approaches c, which is similar to k times the limit. Okay, so for example, if we have the limit of 5 times f of x as x approaches c, so it would be similar to 5 times the limit of f of x as x approaches c. Okay, so moingon ta nga ang limit aning whole, ang limit sa f of x tahay is equal to as x approaches c, ito tayong ibutang 0. So i-substitute din nato 0, so therefore we have 5 times 0 is equal to 0. Okay. So another thing is if we have the limit of -8 times f of x as x approaches c, so it would be the same as the negative of 8 times the limit of the function as x approaches c. Okay, so for example, ang limit of f of x as x approaches c is equal to 5. Therefore, we can say that this one would be similar to -8 times 5, which is similar to -40. Okay? Yes. Okay, next is the addition theorem. So this says that the limit of a sum of functions is the sum of the limits of the individual functions. Subtraction is also included in this law. That is, the limit of a difference of functions is the difference of their limits. So meaning, we're going to find the limit of f of x plus g of x as x approaches c. So in this case, we are going to find the limit first of f of x as x approaches c, then to be added to the limit of g of x as x approaches c. So for example, the first limit is L and the second limit is M. We are simply to add limit of L plus M. And to find the difference, the limit of the difference of f of x minus g of x as x approaches c is similar to finding the limit of f of x as x approaches c minus the limit of g of x as x approaches c. That is similar to the limit of f of x as x approaches c is L and the limit of g of x as x approaches c is M. So just subtract L minus M. So if for example nasolve na tahay nato nga ang limit of f of x as x approaches c is 8 and the limit of f of x g of x as x approaches c is equal to negative 13. So to find the limit of f of x plus g of x as x approaches c is equal to 8 plus the negative of 13, or that would be equal to negative 5. So just add the two values of the two functions. Okay. Next is we have the multiplication theorem. So this states that this is quite similar to the addition theorem, with multiplication replacing addition as the operation involved. Thus, the limit of a product of functions is equal to the product of their limits. So we have the limit of f of x times g of x as x approaches c is similar to the limit of f of x as x approaches c times the limit of g of x as x approaches c. So if ang f of x, limit sa f of x is L and the limit of g of x is M, just simply multiply L times M. So in our example, so since the limit of f of x as x approaches c is 8 and the limit of g of x as x approaches c is negative 13, so ang ato ra buhaton is to find the limit of f of x times g of x as x approaches c. So just multiply 8 times negative 13, which is equal to the negative of pila man na 104. Ako ba? 8 times 3 is 24 times 2. So 8 times 1 is 8, 9, 10. So that's it. Okay, so next is the division theorem. Okay, so it says that the limit of a quotient of functions is equal to the quotient of the limits of the individual functions, provided that the denominator limit is not equal to 0, because if the limit of the function of the denominator is 0, then the whole limit is undefined. So ato ra siyang i-divide. So in our example here, using kana nga example above, so if we are going to find the limit of f of x over g of x as x approaches c, so we are going to find the quotient of 8 divided by negative 13. So pwede no, kay ang atong limit of g of x is negative 13 man. So therefore, mora na. Or we are going to divide 8 by 13 para mahimong decimal point. Okay? So if another situation is ang limit of f of x as x approaches c is 0, for example, and the limit of f of x or g of x as x approaches c is 8. So ang limit of f of x over g of x as x approaches c is equal to 0 over 8 or 0. Whereas, ugwi ang atong pangitaon is ang limit of g of x over f of x as x approaches c, it becomes 8 over 0. So since ang denominator is 0, therefore we can say that the limit does not exist. Okay, it's undefined man. Okay. Next is we have the Power Theorem. Okay, so this theorem states that the limit of an integer power p of a function is just that power of the limit of the function. That if we are going to find the limit of f of x to the power of p as x approaches c is equal to the limit of the function f of x as x approaches c to the power of p, or the limit raised to the power of p. Okay, so for example, if the limit of f of x as x approaches c is equal to 9, and the given situation is find the limit of f of x as x approaches c. Tayo ato na imbutang to the raised exponent 4 na siya. So it should be 9 to the power of 4, no, which is similar to multiply 9 times 9 times 9 times 9. Okay. So another situation, if we have the limit of f of x as x approaches c is equal to negative 2, and if we are going to evaluate the limit of the function exponent negative 2 as x approaches c, so replacing the value, which is negative 2, so we have negative 2 to the negative 2. So in order to make the exponent negative to positive, so ato hinumoning negative 1/2 to the power of 2. So it becomes 1/4. So the value of the limit is 1/4. Okay? And the last limit law is about the radical root theorem. So this theorem states that if n is a positive integer, the limit of the nth root of a function is just the nth root of the limit of the function, provided the nth root of the limit is a real number. Thus, it is important to keep in mind that if n is even, the limit of the function must be positive. Okay, so that is the limit of the nth root of f of x as x approaches c is similar to the nth root of the limit of the function as x approaches c, or it is the same as the nth root of the limit, or L. So, for example, if we are given that the limit of the function f as x approaches c is equal to 16, so in order to find the limit of the square root of f of x as x approaches c is equal to the limit of the square root of 16 as x approaches c is equal to 4. Okay, so another is, for example, if we have the limit of f of x as x approaches c is equal to -9. So to find the limit of f of x as x approaches c is the limit of the function. So since ang limit nato kay ang limit kay -9 man, so take the square root of kung square root tayo na, so the limit of the square root of f of x as x approaches c atong pangitaon. So since this is -9 and there is no such value of the square root of -9, kaya ma-undefined naman po na, no? So therefore, we can say that the limit does not exist because it is not a real number. Okay, so that is all for this topic. I hope you learn, or you have understood the different situation, and the next audio video lesson will be talking about application of this limit theorems. So we are going to find the limits of polynomial, rational, and radical functions. So that will be all for today. Thank you and God bless.